Welcome to my projectbazaar.com. We discuss about spectrum hour mobility management in cognitive radio cellular network. Cognitive radio network have been proposed as a solution to both spectral inefficiency and spectrum efficiency. However, they face several challenges based on the fluctuation nature of the available spectrum, making it more difficult to support seamless communication, especially in cellular radio network. In this paper, a spectrum hour mobility management schemes based on this architecture, a uniformed mobility management framework is developed to support derives the mobility events in CR network. Management schemes determine a target cell and spectrum bands for CR user adaptively depend on the time varying spectrum machine so as to minimize a switching latency at the cell boundary by considering spatially heterogeneous spectrum available. Intercell resource allocation helps to improve the performance of both mobility management schemes by efficiently sharing spectrum ratios with multiple cells. Simulation result shows that the proposed method can achieve better performance than conventional handoff schemes in terms of both cell capacity as well as mobility support in communication. Now let's discuss about the flow diagram. First of all, the network creation depends upon the primary users and the second user. Primary user has a license to operate in a certain spectrum band. This access can be only controlled by its base station and should not be affected by the operation of any other unauthorized users. In primary base station is a fixed infrastructure network component which has a spectrum license. In principle, the primary base station does not have any cognitive radio capability for sharing the spectrum with cognitive radio users. However, primary base station may be required to have both latency and cognitive radio protocol for the primary network access of cognitive radio users. The channel allocation depends upon the cognitive radio user has no spectrum license. Hence, the spectrum access is of the cognitive radio user include the spectrum sensing, spectrum decision, spectrum handoff, and cognitive radio MAC routing transport protocol. The cognitive radio user is assumed to have the capability to communicate with not only the base station but also other cognitive radio users. The cognitive radio base station cognitive radio is a fixed infrastructure component with cognitive radio capability to provide single hop connection to cognitive radio users without spectrum access license. It can be depends upon the channel accessing technique and channel sensing technique. Channel allocation for each primary user is assigned the time slot of the frame period. The CSI information throws the feedback channel. Its capability of n is the number of packet in this buffer, m is the estimating number of the packet it can be transmitted based on CSI. If n is greater than theta of c, the number of packet to be transferred the base stations. The channel sensing schemes, the values calculated BR is considered the values derived from the calculation made for configurations exploiting CSI for the previous steps of the channel estimation phase of the cognitive radio process. Convergence is identified if the following condition hold. The calculated BR value is the same with that of the previous invocations. The probability BR calculation BR equal to BR, CFG equal to CFG is larger than all the rest. In case there is no convergence, the variable up D is the set of its 0. The choosing the optimal decision choosing the optimal decision, the novel algorithm that solves efficiently the problem of spectral sharing and user scheduling in cognitive downlink MIMO link systems. We design a low complexity greedy algorithm following we add the well-known proportional fairness to the proposed algorithm in order to ensure time-based fairness and to resolve the efficiently fairness sun rate of output. It gives the analyzing the output, the cognitive primary users and secondary user. First we creating the nodes. The nodes will be creating into the separated manner. We creating the number of users for 16 users, number of channels for 4. Now we using for DCA performance. It can be allocating, do you want to allocate the channel to first primary users and second users? If you want yes means we press for yes, if you don't want miss, if you press for no. The power spectral density output will be shown. We see about the mobility management performance. It is depending for mobility management availability of extension spectrums, how the performance will be available, and high capacity rate and high reliable rate. What is the fixed point? We are already we have calculated in this project. Mobility management. Then we find it for link efficiency. The links efficiency we have finding for user velocity, cell capacity, and the cell capacity of the rate, user velocity of the rate. We have those things are we have analyzed. This is represented for cell capacity for 10, 20, 30, 40, 50, 70 and 100. Total of the efficiency of the value of cell capacity values and the link efficiency values will be calculated. This is for output of the cell capacity into the link efficiency values. Now we discussing about the user velocity. It is for link efficiency and user velocity of the each of the users will be particular kilometer we allocating that we calculating the link efficiency values. It is represented for user capacity and cell capacity. It is the handoff performance of second user. Handoff probability values will be calculated for individual number of sub users. Thank you.